Hey, what's happening, guys? Welcome to 2022. Hope you're having a good time so far. Today we're going to take a look at this. This is the TikStation. It is a breadboard and more portable power supply, multiple voltages, multiple rails that you can use for your projects. This is created by a guy named Oled. I hope I pronounced that right. And if you go to TikStation.com, you can find the details. And it is a Kickstarter. So first of all, the packaging is excellent. It's superb. Very nice job done here. Inside the box, we get a USB charger. Output 5 volts at 3 amp, 9 volts at 2.77. What else am I seeing? 3.3 to 5.9 volt at 3 amp, or 3.3 to 11 at 2.5. So this is a multi-voltage USB-C power supply. Here's the TikStation itself, and it is attached currently with these little screw terminals. But what makes it really nice, you can pull those out and plug this right into your breadboard. I can get them all the pins lined up, and that is a factor, function, whatever you want to call it, of these cheap Chinese breadboards. Not Mr. Isa's engineering, which is just fine. 1 second, please. There we go. Just had to finagle the pins a little bit to get it to fit in there. It's looking pretty good. As you can see, we have 5 volt rail and ground here, 3.3 volt and ground there, minus 12 volt here, plus 12 volt here, and adjustable here and here. So that's really nice. Looking down through here, the work just seems quite good. The board joiners here are soldered. Very nice. Here's our pots for the adjustable voltage. Let's plug it in and see. See what there is to see, right? Okay, so it's powered up. Power off. Power on. Let's take a look here at the instruction manual. Adjustable outlets. Ensures uniform thermal distribution for less heating and prolonged life. They've even included a nice little screwdriver for adjusting our adjustable voltages, which is really nice. So let's put a load on this and see what we can see. All right, let's start with 3.3 volts, which is that rail there. Brought in the meter here. Adjust the camera a little bit so we can see better, huh? And light her up. 3.319 on an open circuit. So what we'll do is we'll put a 100 ohm resistor in there. And then LED. It doesn't seem to want to light. Yeah, if I put the LED in the correct way, then then it works okay. So, measuring that voltage. Looking at 2 volts across the LED. And we hook this up to the oscilloscope and see how it how the wave looks, how flat it is, whether or not we're experiencing any ripple. I doubt we are, but we'll take a look. All right, I have the oscilloscope probe hooked up on the anode of the LED and ground. Then we're going to come up here to the oscilloscope and have a look-see. Hang on. All right, so we're looking at a 50 millivolts per division. So the biggest spikes we're seeing, 1, 2, 4 divisions, 200 millivolts. It's a little spiky. It's not terrible. It's not fantastic. It is passable. All right, let's come around here and move, and we'll take a look at the next voltage range. So I'm going to switch to a 1K resistor. And we got it on the 12 volt range. So let's hook it up. And we'll see what there is to see about that. Now, I was going to say it's already looking better, but, well, heck. Just seems to be right back where we were, huh? Yeah, it's pretty good. It's mostly smooth. I'm seeing maybe 20, 30 millivolt spikes, which is not bad at all. Yeah, not bad at all. Very good. Let's take a look at the adjustable voltage. Disconnect the oscilloscope here. Take out our LED in this guy. Bring in the meter. We'll leave the ground hooked up there. And if I look at this bottom adjustable here, what are we getting? Wow, 20 volts. And the top adjust, 19 volts. So let's adjust that, hopefully. Down to about 5 volts, I'm hoping. And we're getting there. Let's see, how are we doing now? 15 volts. Give me a second. $15, $14, $13, $10, $8, $7, $6, $5.7. I know you can't see that. $5.5, $5.3. We can get it right in there. 5.02. And is that the same for the bottom adjust? Yeah, so those are the same. All right, so what did I do with my other resistor? Hang on again. All right, so we'll put a 1K resistor in there. And again, it helps by plugging it in the right direction, doesn't it? There we go. So let's hook up to our ground. Get a voltage reading. What's our output looking like now? 5.02, perfect. Looking good. We'll hook this up to the oscilloscope here. We'll have a look at the waveform. So the 5-volt is looking a little bit spikier. A lot more like the 3-volt. Not in the same range, I would say. But still not a problem. All right, we're just looking at this on the phone on the computer here. This is the Kickstarter. There's the address. I'll put it down below. He is at $12,403 of his $26,000 goal. He's got 173 backers. Now, what I find interesting, it's on here. I might have to go backwards. There it is. An OLED display will be added. Well, that's neat. So somewhere there's got to be a I2C on this board. Let's see if we can find it. Disconnect everything here. I don't see an I2C interface, but that doesn't mean anything. Could be hiding on this board. It could be something that he's planning on adding later on. I just think it's neat. It's a nice thing to be able to display the voltages. I like it. So that's pretty cool. I want to thank Mr. Issa for sending this out to us for our consideration. I'm just trying to line things up here, pardon me. My brain often doesn't do multiple things at once. Well, there we go. This is a nice project. I like it. I think he's done a really nice job with it. So I'll put the addresses down below. If you're interested, you can get in touch and perhaps get yourself one of these bad boys for your projects at home. If you enjoyed this video, I hope you'll give me a thumbs up. Feel free and comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you guys for watching. That's it. I'm out. Peace.